Today we're going to be taking a look at modeling polynomial division. Since division is the inverse operation of multiplication, it works a lot like multiplication. To understand polynomial division, we're going to be using the sharing model and the area model. Let's start by taking a look at the sharing model. How can we use the sharing model to solve 8y divided by 2? We need to ask ourselves, how can I divide 8y tiles into two identical groups? You probably recognized that 8y tiles can be divided into two identical groups by putting 4y tiles in each group, as I've shown you below. Using the sharing model, we've determined that 8y divided by 2 is equal to 4y. How can we use the sharing model to solve 6x squared divided by 3? Ask yourselves, how can I divide 6x squared tiles into three identical groups? To make three identical groups with 6x squared tiles, we would have to place 2x squared tiles into each group. That tells us that 6x squared divided by 3 is equal to 2x squared. The quotient is the amount of tiles that we've placed in each group. So using the sharing model, we have determined that 6x squared divided by 3 is equal to 2x squared. Why don't you try this question on your own? Use the sharing model to solve 9x plus 3 divided by 3. Ask yourself, how can I divide 9x tiles and the 3-unit tiles into three identical groups? Pause the video and take a look at this. You probably determined that to make three identical groups with 9x tiles and 3-unit tiles, each group would have 3x tiles and 1 unit tile. So using the sharing model, we have determined that 9x plus 3 divided by 3 is equal to 3x plus 1. So here's a question. Do you think that the sharing model will always work to represent polynomial division? Well, the answer is nope. How would you model 10x squared plus 10x divided into 5x groups? You can't. We don't have a way to model 5x groups. Or how about 3x to the 4 plus 6x cubed plus 4x divided by 2? How are you going to model 3x to the 4 divided into two groups? You can't. Let's take a look at using the area model to solve polynomial division. In this example, we've been asked to solve 3x squared divided by x. So as you can see, I've got it set up in our T shape. We've got an area that's filled in and is equal to 3x squared, and that is our dividend. We've divided by x, that's our divisor. We know that it's x because of the horizontal width of our area. Looking at the vertical length of our area is going to tell us what the quotient of this expression is, or what the answer to this question is. So it's going to tell us the quotient. Looking at each tile, we know that an x squared tile has a vertical length of x. A vertical length of x and a vertical length of x. So the tile that has a vertical length of x and a width of 1 that would fill this area would be your x tile. Another x tile and another x tile. You may be using the area trays in class, and you could use that to represent the same example. So based on the area model, we have determined that 3x squared divided by x is equal to 3x. If we wanted to verify our answer, we could perform the inverse operation, so multiply this out, taking our 3x, multiplying it by x, and we should get the area that we started with. 3x times x is 3x squared. And looking at it with our tiles, because it looks a little bit neater, we can see that 3x squared divided by x is equal to 3x. Let's take a look at another example. Use the area model to solve for the following. As you can see, we have our area, which is our dividend, our vertical length, which is our divisor, and it will be our horizontal width in this example, which will tell us the quotient. Let's first take a look at the actual area. We have an XY tile, another XY tile, and we have 3 negative Y tiles. Looking at the vertical length of this area, we can see that the length was Y. The horizontal width of our XY tile is an X tile that would fill this space because it's X long and 1 wide. Another X tile. Each of these negative Y tiles would be 1 wide. But looking over here to the left, we can see that this vertical length was a positive Y. If these tiles are negative, we know that the width must have been a negative 1 tile in order to make that negative Y, because a negative times a positive is what gives us that negative Y. So we have determined that 2xy subtract 3y, which was our area, divided by y, which was our divisor, is equal to 2x subtract 3. And here we have the example model with tiles. It looks a little neater than my drawing. You can see the area that was 2xy subtract 3y. It was divided by our divisor of y. And this was equal to 2x subtract 3. What if we wanted to verify our answer? Do you remember? We take our quotient, we multiply it by the divisor, and you should get the dividend if your answer of 2x subtract 3 was right. Let's try that out. Y multiplied by 2x subtract 3. Remember, we have to use our distributive property when we're multiplying. So that means the y must be multiplied by the 2x, and the y must be multiplied by the negative 3. So y times 2x would give us 2xy, and the y times a negative 3 is negative 3y. So there we've checked our answer, and we can see that we were correct. So now it's time for you to try an example of your own. Use the area model to solve. Take a look at the area that's filled, which is your dividend. Look at the vertical length of this area, which is your divisor. The horizontal width will help you find your quotient. As you're doing this question, write out the equation that's modeled in this example. Also, how can you relate this equation to multiplication? Pause the video, copy down the example, and take your time. So your dividend is based on your area. Because you had 6 y squared tiles, and 4 y tiles, we can say that 6y squared plus 4y, and the vertical length was 2y, was being divided by 2y. Horizontal width is what's going to help us solve this expression. This y squared tile has a horizontal width of y. We know it's positive because our y squared tile is positive, and a positive multiplied by a positive gives us a positive. Or we can look at it in reverse. Positive divided by that positive gave us that positive y tile. Again, a horizontal width of y gives us another y tile. And another, so a third y tile. These y tiles have a width of 1, and they're positive y tiles, and a positive y divided by that positive y would give us a positive. And another positive 1. We've determined that 6y squared plus 4y divided by 2y was equal to this width of 3y plus 2. This relates to multiplication because it is the inverse operation. And here I have it modeled with tiles. We have the same answer, just a little bit neater. 6y squared plus 4y divided by 2y was equal to 3y plus 2. If we want to write this out in a multiplication statement, 2y multiplied by 3y plus 2 is equal to, using our distributive property, multiply the numerical coefficients. 2 times 3 is 6. Y times y is y squared. 2y times 2. 2y times 2 is 4y. Do you think that the area model will always work to represent polynomial division? Well, the answer is nope. How would you model 3x to the 4 plus 6x cubed plus 4x divided by 2? You can't. This is why we will be learning to divide polynomials symbolically, in other words, mathematically. So here's your to-do. For your entrance slip tomorrow, find the quotient of a polynomial and a monomial using the sharing model or area model. Have a good one.